Hi there. Welcome to the sort of summary video for our lesson 6.6. We were doing some work with Pythagorean theorem, but we were doing some word problems today. And normally when we're not distance learning, I'd have you draw the pictures and stuff. But in order to make things a little bit more manageable, I decided to assist you by sort of giving you a picture and then letting you label it. So I'm going to do these one by one, and I'm going to go as quickly as I can. You can pause if you need to. The first one we looked at was about a ladder, right? So it says a 25-foot ladder is leaning against a wall. So you have a triangle here, and what I'm going to do is I'm going to sort of label this as I go. So the ladder is leaning. So to my mind, that kind of looks like the ladder side. It says the base of the ladder is 7 feet from the wall. So the bottom of the ladder is here and the bottom of the wall is here. That must mean that here's the base of the ladder. So how high up the wall does the ladder reach? And so then I label this is the height that I'm looking for, right? So by using the words to label the diagram, now I can see that it's just a regular old right triangle problem. And I can solve it with the Pythagorean theorem. I don't know anything about the angles. I just know two of the sides. And so then to find the solution, I would probably pull out a piece of paper and note that the legs, A and B, one of them is 7 and the other one is just unknown. And then the hypotenuse, C, is the length of the ladder. And then we're just going to solve this really fast. 7 times 7 is 49. 25 times 25 is 625. And then I'll subtract 49 from each side. And that means that b squared is 576. And then finally, I'm going to take the square root of that. And luckily, 576, that's a perfect square. It's actually 24 squared. So it turns out that it reaches 24 feet up the wall. And that's sort of basically the two things that I want you to do is label the triangle, but then use the labeled triangle to find the missing value. So let's go back and look at another one. All right, so Scott the river swimmer. I do think I probably could have made this diagram a little bit easier to understand, but if you start on this side of the river and then you start swimming across the river, here on the bottom side of the river, and you swim across to the top side, you wouldn't swim straight across because the current is going to pull you downstream. Instead, you'd swim along this diagonal line here. So it says Scott wants to swim across a river that's 400 meters wide. So that's this leg of the triangle is 400 meters straight across. He begins swimming perpendicular to the shore that he started from, but he ends up 100 meters downriver. So the current pulls him so that he actually ends up down here at the end of this diagonal line. So how far did he actually swim? So that means, oops, not this. The distance that Scott swam is this diagonal line here. So it's another right triangle that we can solve with the Pythagorean theorem. And this time, the unknown value is the hypotenuse, but I do know both legs, A and B. So we would just do 400 squared plus 100 squared equals C squared. And it's, 400 squared is 16 with 4 zeros, or 160,000. 100 squared is 1 with 4 zeros, or 10,000. And that's 170,000 when you add those together. And you can use a calculator for this. So you take the square root of 170,000, I think you get 412.3 meters. So just a little bit more, right, than the distance across. So this was 412.3 meters. Let's look at the next one. We're going to do 5 problems like this. So the next one is about a wheelchair ramp. And this is true that the proper slope for a wheelchair ramp is 1 inch of rise for every 12 inches of run. The slope is 1/12. So Gianna needs to build a wheelchair ramp that rises 2.5 feet, which means it needs to start 30 feet, which is 2.5 times 12, from the end point along the ground. So how long will the ramp be? Obviously, it needs to rise up 2.5 feet like this, and it needs to start 30 feet away. So what's the length of the ramp? And so we've got this really, really sort of shallow right triangle, but it is a right triangle. And you can see that the ramp is not going to be much longer than this, the length along the bottom that it needs to run, but it does need to be a little bit longer. And so we go and we note that, again, I know the 2 legs. I know 1 leg and 2 legs, but what I don't know is the length of the hypotenuse. So we'll use the Pythagorean theorem again. 2.5 squared plus 30 squared equals C squared. Now, When you square the numbers, they get much, the value gets much longer. 30 to the second power is 900. But 2.5 to the second power is only 6.25. So the difference between 2.5 and 30 is, well, what is that, 27.5? But the difference between these is much greater. So when I add them together, it's just 906.25, which is pretty close to 900. And then when you take the square root, if you round it, you get just 30.1. So it's really just like another 1/10 of a foot in length. And that makes sense. Sort of the shorter one of the legs is, then the closer the other leg and the hypotenuse are going to be to being equal. Okay, so there's 2 more problems to do, and these involve special right triangles. So a new escalator is being installed in an office building. The escalator is going to be 60 feet long. So an escalator goes from one floor to the next, so that's 60 feet. And it will make a 45-degree angle with the ground. Okay, so that must be 45 degrees here. So how high up will the escalator go? And so this is the height. All right, so we've got a 45, 45, 90 triangle. And so now, for these problems, we use this proportional relationship that 2 sides are the same. And the third side is the length of these 2 sides times the square root of 2. And I know that that's 60 feet. So I'll write x root 2 equals 60, and I'm going to solve from there. And I'm going to divide by the square root of 2. And I got x equals 60 divided by the square root of 2. But now I'm going to rationalize that denominator, because an irrational number like the square root of 2 in the denominator makes me want to puke. Okay, so it's easy to do this, because we can just multiply, as you saw in the last video, by root 2 over root 2, and we get 60 times the square root of 2 divided by 2. Because the square root of 2 times the square root of 2 is just 2. And now I have this nice integer in the denominator. And then I can actually reduce that. It's 30 times the square root of 2. So the length of this is 30 root 2, which if you use a calculator to do 30 times the square root of 2, it's like 42.4 feet, I think, when you round it to the nearest tenth. All right, one more problem, and this one is, I think, more challenging than anything I would give you to do on a test, but still a good one to look at. So the pitch of a symmetric roof on a house that's 40 feet wide is 30 degrees. So the house itself is 40 feet wide. So I can say that the entire width of the house is 40, and the pitch means, like, the angle between the flat top of the house and the roof itself. So that's a 30-degree angle. What's the length of the roof itself? So we're looking for this length here. And because it's symmetric, we have a 90-degree angle. So we end up with another special right triangle, a 30, 60, 90 in this case. So the difficulty here is to realize that if this is symmetrical, then this part is 20 feet. And in a 30, 60, 90, we call the short side x, the long side that we're looking for 2x, but the side that we know is 20 is x root 3. Okay, so now I'm going to solve this one just like I solved the last one by writing an equation. X root 3 equals 20, because it's half of 40. And I'm going to divide by the square root of 3 on both sides. So x equals 20 divided by the square root of 3. And then I'm going to rationalize that denominator by multiplying by root 3 over root 3. This irrational denominator is gross, so let's make it a regular old 3, because root 3 times root 3 is 3. And then on top, I have 20 times the square root of 3. So the height of this height here, whatever it is in a calculator, but you could approximate it, but it's 20 root 3 over 3. And then finding this length, which is what I'm actually setting out to find, that's just 40 root 3 over 3. I double this, right? That's x, so I double it. And then on a calculator, I believe you get 23.1 feet if you do 40 times the square root of 3 and then divide it by 3. And so those were the 5 problems that we did in class, and there are going to be 2 problems a lot like those on the upcoming test. So I would go and try to solve those yourself whenever you get a chance. But these solutions are here for you if you need them. See you next time.